from the data and options, double click times. So we will give EPANET a daily water consumption pattern. So because, as you know, for example, in the night, nobody consumes water. But in the morning, the water usage is very high maybe. So we will describe this pattern. Actually, this is the reason why we use tanks. The tanks work as a daily regulators. In the night, the water will be stored in the tank, and in the morning, we will use the water in the tank. So by this way, I will not have to run my pump for 24 hours. Okay? But if your source is below your residential area, of course, you have to run it to pump it. Okay? In that case, maybe you can put your tank here. Actually, these are the things that you will decide in the project. You will use your engineering judgment and you will decide these things. Now, I want to run my system for 24 hours. Hydraulic time step. This is the time step that EPANET use for its own calculations. This is not about me, this is about EPANET. But if you decrease this time step, it will be more precise. For example, let's give it 15 minutes. Quality time step. EPANET can make quality analysis water quality, but we will not use it for this course, so we will not change this one. Pattern time step. Okay, you can take this pattern from the guide that I will share with you from the Turkish regulations. Now I will open it and show. This is the regulation that you will use. I will share with you. It is Turkish, but most probably every group will have at least one Turkish member. So your Turkish member can read these numbers. Now I'm looking for the pattern that I'm mentioning. Yes, this one. This table says, for example, if your area's population is below 5,000, you can multiply the water consumption by these numbers. For example, the default number is 1, but in the times between in the morning 6 and 9, water consumption is 1.7 times higher than the normal one. Okay, so as we can see in this pattern, there are 3 hours, 3, 3, 3, but for this one only 9. So we can assume this one as 3 times 3 hours. You can add a new column here from 21 to 24, 0.4 again. From 0 to 3, 0.4, etc. So by entering these numbers to pattern, we will obtain a new solution. I have written for pattern time step as 3 hours, pattern start time 0, reporting. Maybe I wonder what is the water consumption in the morning 7:30, because if it is 1, I can take only at 7 o'clock and 8 o'clock, but I wonder the data at the 7:30, so I want a precision which is half an hour. Let's write 30 minutes, and report will start from the beginning clock start time. So your pattern will start from 12 a.m. from midnight. Okay, now we can close. And now we will describe the pattern. Browser data pattern. By clicking this one, we will add our new pattern. The multiplier. Now I will write the numbers which is in the Turkish regulations. It was 3 hours, so there should be 8 multipliers, because 3 times 8 is 24 hours. From midnight to 3 o'clock in the night, what was the multiplier? Please take a picture of this screen, and if I make it wrong, please correct me. From 21 to midnight 0.4, so that means from midnight to 3 again it should be 0.4. Okay, let's enter the values. 0.4. 2, this means from 3 to 6 o'clock, again it should be 0.4. This means from 6 to 9 o'clock. By the way, I am using the population is below 5,000. The first row. This is 1.72. This is 0.82. 1.7. 0.81. 1.75, and this is the last multiplier, which is in the evening from 9 o'clock to midnight, 0.4. Okay, let's check the pattern. Yes, I think the pattern is a pop-up window. It needs a new share. I am not sure whether you can see it or not. Now I have described a new pattern, water consumption pattern, but my junctions don't know it, so I should inform my junctions. For example, double click demand pattern, nothing writes here. Now I will show you how to make changes of many things together. Edit and select all. Now I have selected all of the things in the screen, but I will just change the properties of the junctions. Again, edit and group edit. Yes, you can see the little pop-up window, right?
Yes, sir.
Okay, for all junctions, replace demand pattern with Its name was, as I remember, PT1. Replace for all junctions, replace demand pattern with PT1. Okay. 6 junctions were updated. Okay, let's check. For example, this one, yes, demand pattern is pattern 1. Okay. Let's run it again. Run was successful again. Okay. Now I can see at the time, at the beginning, 0 hours. But by sliding this one, I can see any result during the day. And by clicking this one, you can animate the results. Look, now the hours are changing. Look, the colors are changing depending on the daily consumption. Okay, so from, for example, at 9 hours, what's happening here, I can see. And if you want to arrange the scala of these legends, you can right click it and you can arrange the colors here. In your project, you will take the values from the regulation. Again, the Turkish regulation, for example, the regulation says all the pressure inside the distribution system between, for example, 30 and 50 meter water columns. So that means you will arrange this green area because this is the acceptable area. For example, from 30 to 50. And you can arrange these ones. Okay. Now they are changed. And for example, the regulation says all the velocity in the pipes should be between 1 and 2 meters per second, for example. And you can arrange. Okay. And let's check these ones. For example, table. You can show the results as a table. For example, at junction 2, at this junction, which is just after the pump, time series for node, how does the pressure is changing during the day in this junction? I wonder that. So in the columns, I will just choose pressure, filter, no filter, click OK. Yes. At the beginning of the day, at midnight, the pressure is 45 meters. And it is changing during the day. You can observe the results from table. Or I wonder, for example, the velocity in the all pipes. So network links at, for example, let's change the time. The afternoon. Columns. I just wonder the velocity. Yes. For pipe 1, it is 0.4 meter per second. Pipe 2, 0.05 meter per second, etc. You have to arrange your pipe diameters depending on your velocities as well. Because if the regulation says you shouldn't exceed this velocity. That means you have to increase your pipe diameter. And graph. Now we will show the results as graphs, not as tables. For example, time series for nodes. Again, junction 4 is selected. Let's delete it. For example, for this one, junction 6. At junction 6, how does the pressure changes during the day? This is the graph of change of pressure with respect to time during 24 hours. What else here? Query this one. For example, if you want to find nodes with which is pressure is below, for example, 10 meters. There is no, let's say 20 meters. 50. Yes. While you are checking your project, for example, if regulation says all the pressures should be higher than 50 meters, you can write you 50 and check whether there is a pressure below 50 or not by using this query. Okay. Any question? Can you hear me?
Yes, sir.
Yes, hocam.
Okay. Now I will show you, I think it is the last thing before the data. After that, I will give you your data for the project. There are some controls. You can see, I think, controls are statements that determine how the network is operated over time. They specify the status of selected links as a function of time, tank water levels, and pressures at selected points within the network. There are two categories of controls that can be used: simple and rule-based controls. For example, this is an example. Link X status is open or closed. For example, link 5 is closed if node 3 is below 20 meters. Again, I will share EPANET. For example, you can say that if the water elevation inside this tank it is maximum level 6, but yes, it is dimension is 6 meters, it is 86 meters, but I don't want the water level to exceed 5 meters. Okay, so you can say EPANET, if the water level in this tank exceeds 5 meters, stop this pump, stop operating this pump. And of course, this is not enough, because if the software stops the pump, it will be stopped eternally. So you have to open it again. You have to describe another comment, which is like, if the water level in the tank is below, for example, 3 meters, open the pump again. You can use this kind of controls. How can you do it? data controls. Simple, double click. You will write controls here. Now I will open the file that I have created before, because you should find these controls by trial and error, not to lose much time. I will open a new file. First, let's save this one. Maybe we can use it in the future. Yes, this is the project that I have created before. I have described the controls for this one. Controls, simple. Yes, for example, what I did right here, link pump 1 is 2. 2 means run this pump 2 times stronger than regular. If tank 8 below 1, because I see that the tank is emptying. This is an emergency. The water level is below 1. So I said EPANET, run this pump 2 times stronger. And as I said, if I don't write this text, it will run 2 times stronger eternally. So I should stop it somewhere. I wrote here, again, link pump 1 is 1. That means the normal power, if node T8 is above 5. I will show you some extra examples about this. EPANET has its own examples embedded inside it. File, open. In your computer, you can find it. Program files, EPANET examples. You have these files as well. You can find them. For example, let's open net3. Run. You can use these files to have an idea about EPANET usage. For example, let's check what did they describe as controls. Controls, simple, double click. Lake source operates only part of the day. Link 10 open at time 1. But I cannot see the IDs, so first let's show the IDs. Display node IDs, display link IDs, okay. Link 10 open at time 1. If you write time, that means timestamp, not the clock. They are all described in the user manual. So, and link 10 close at time 15. The lake source, this lake operates only from 1 to 15, for example. This is a detailed thing, but maybe you will use. Now, let's open another example. There is no control in this project. Yes, for this is a very simple project. It says link 9, but again I cannot see. I should open the labels. Link 9 open if node 2 is tank below 110. So they want to operate the pump only if the water level in the tank is below 110. And when the water level in the tank reaches to 140, they will close the pump. Okay. Any question?